Hello friends, so today we will talk about RAGs. So as you all know, RAG, also known as Retrieval-Augmented Generation, where you feed all your data in a database, and then on the runtime, LLM fetch the data from your vector database or any other database that you have configured and give you results. So today we will review two awesome blogs on how to make your RAGs more efficient and how to supercharge your RAGs. Okay, so first let's start with a little bit introduction so that anybody who don't have any context of what RAG is and how does it work gets little bit familiar, and also we'll talk about like when to use RAG, when not to use RAG for 1 minute, and then we will jump on the blogs. So basically, as you know, right, so there is a prompt when we use any LLM, let's say ChatGPT or Cloud or Gemini. There is a prompt that we give to the Gemini, and then basically that particular LLM, whatever it is, it generates the response corresponding to that prompt. So limitation of that prompt is that it can't be greater than a certain length, right? Max length of the prompt can vary as per the LLM provider, but almost all the providers have a very finite length of prompt. So basically that's where the real need of RAG comes into picture, where you can't provide your whole history. Let's say you are building a assistant for you, right? Now you have a lot of data from your knowledge base, from your GitHub repository, from your Jira, from your Slack. So that is a lot of information, right? And you can't feed all that information in one prompt, right? So now you need some strategy to ensure that your LLM is able to access that information, and that's where RAGs come into picture, where you feed all that data in some form into a database, and then you pull that data on the runtime, and you instruct your LLM that okay, you start by pulling the relevant data from the database, and then based on that data you generate the answer for me. So it has few advantages. So basically first it helps to reduce your cost, because now you are feeding only required amount of tokens into your LLM, and your length of your prompt etc reduces, and yeah, so speed also improves over the time. So there are some benefits of using RAGs as well. So now lot of people build RAGs, but they lack correctness, right? So basically basically the chunks that LLM extracts out of the database are not so relevant for the question you are asking to the LLM, and you get suboptimal result, or like a generic result, not a very use case specific result, right? So there are few techniques that we can use to improve the quality of the RAG. So we will discuss two blogs. That one is written by this Anthropic and parent company that developed Cloud. Then another blog that I really liked reading was Modern BERT. So this is also a very good blog, and I'll tell you why in like 5 minutes. But yeah, first we'll start with this blog by Anthropic. So and in this blog there are at least 2-3 strategies that we will learn today. To improve, and it will really help you improve the correctness of the results being produced by LLM that is powered by RAG. So let's get started. And so for today's video we will just focus on correctness, and will not focus on other matrices like latency, which are also important sometimes, but for most of the use cases correctness is the major metric that you want to improve. So I will not go through the whole blog, but will pick up few things from the blog. So first thing, as you mentioned, as I already mentioned that, right, they have also written sometimes the simplest solution is the best. If your knowledge base is smaller than these many tokens, you can just include your entire knowledge base in the prompt. So as I mentioned, like RAGs are important when you have a lot of data, right? You can't put all the data in one prompt. But if your data is less, then you can definitely use a prompt, and people have also launched prompt caching, etc., that you can use to reduce your cost. So that is one point, right? Now the second point is, how does RAG work? So basically, generally, but when we talk about RAGs, most of the people say, okay, feed your data in vector database, right? And then use a metric like cosine similarity or Euclidean distance to retrieve the similar kind of documents or chunks, right? Although it gives you good result, but sometimes you need exact matches, right? So you need exact matches. For example, let's say you give LLM that okay. Let's say you fed it a whole book of Harry Potter, right? And you ask that, okay, what was the platform in the book, right? So now it will match all the platforms in the book, all the chunks that are related to platform in the book, because like platform is the major keyword, right? Now, but if you ask about platform 3x4, and if you need that particular keyword in your results, right? At that time, generally vector databases lack because they do similarity search. Like basically, what do we say that semantic search, right? That the semantic meaning of the chunk should be similar, right? But there is a very good technique. It's a old technique of BM25. Basically, there is a very good article from Elasticsearch on BM25. So basically, it's best 25 model. So you find k nearest neighbors and find the similar pages from your database that match your keyword, right? So in this blog, let me see. Yeah. So basically over here, they have like written this, but very clearly that they have used TF-IDF encodings and semantic embeddings for these chunks. So they use BM25 along with the semantic embeddings. So what did they do? They use both the techniques. They generated embeddings of the text, and then they fed the text into a document database where they could easily do BM25 search, and then they fetched top k chunks from both the databases, and then they combined the results. And then after combining, they also use techniques like re-ranking, etc., to improve the accuracy of the RAG. So one thing is very evident to me was, I was also of the opinion that okay, if you want to use RAG, put a vector database, put your documents in the vector database, but you can use Elasticsearch as well, right? And you can use best of the both worlds. One is semantic meaning of the sentence or query that you are giving to the RAG, and another thing is exact keyword match, and you can do both type of query and then combine the results, and then when you have combined results, you can feed it into the LLM, right? So this is the first strategy that they have discussed over here. Then the another strategy that they had written in this blog was, if we go little down, yeah. So the second strategy that they have suggested in this blog is, like, you have a large database, right? And you for feeding that data into your vector database, you need to break that data into chunks. But what is the problem in the chunk is a chunk lacks specific information, or basically I would say the context for that chunk, right? Um, let's say it was a very small chunk, one paragraph in the page, which has a lot of context to collect from the top or bottom nodes, or bottom top or bottom paragraphs. So the chunk will miss that information, and when you do similarity search, maybe this chunk is relevant for your query, but since it is missing the context from the above or bottom content of the page, this chunk will not get into top k clusters that you are fetching from the vector database. So to improve the relevancy of each chunk, what they have done is they generated the summary of each chunk, and then they embedded that summary into the end of the chunk, and then they generated the embeddings. So then they have discussed this approach, like you have chunks and then run prompt for every chunk to situate it within the document, and and you have like then context with along with each chunk, and then you put it into the vector database and TF-IDF search, and then you query on top of those chunks. So this is the second technique, which again was highlight of this particular blog, that you generate the summary of each chunk, and then you feed it into the vector database. So you have to process each and every chunk, and you have to be very very mindful about the size of the chunk as well, like how much information should be included in the chunk. So I was reading some another blog another day, so they were saying like, okay, you have to be very mindful when you are generating the chunk. So if you are, let's say, feeding a code to your LLM, right? At that time, let's say one part of your function is in one chunk and another part of your function is in another chunk, it will not make any sense, right? So at that time you need to have very large chunks, right? So you have to be very very careful when you decide the size of your chunks. So that is, I would say, the third strategy. So you have to be very very mindful of the size of your chunk, right? And as we mentioned in the second technique, that you can also add summary to each chunk to increase the similarity. So basically when the similarity search happens, so your chunks get prioritized, or your score of that chunk gets increased. So that was second technique. Third technique was to be really really mindful of size of your chunk, and yeah. So basically chunk boundaries they have also discussed in brief, you have to be very mindful about choice of the chunk size, chunk boundary, and chunk overlap can affect retrieval performance. Embedding model, right? So we will also talk about embedding models. This is also very important topic. So as I mentioned in the start, we will also discuss about modern BERT. So they have also mentioned that the choice of embedding model is going to be very very critical when you are designing a RAG. And then number of chunks, custom contextualizer prompts. So all these techniques you can go through this blog. I'll share the link of this blog. Then you can further boost the performance with re-ranking. So basically after you have retrieved top k chunks, then you can basically re-rank those retrieved chunks based on the relevance to the query. So you can again re-rank those models. I'm saying re-rank those retrieved chunks. Yeah. So this was a very brief blog, very short blog, and but it was a very very good blog and one of the best reads I had so far. This was a great blog I had encountered when I was writing my first draft. Yeah, so we mentioned three techniques. One is BM25 search along with the vector databases. Another was adding summary to each chunk. Then the third was technique that we are going to discuss now, which is from the another blog. This is a modern BERT blog, and it is around the choice of the model you are using for your embeddings, right? So like there are already very good embedding models that are available on Hugging Face, but yeah, so when it comes to choice of the model, you have to be very mindful about the kind of search you are going to have, and so basically these models, for example this BERT model I'm going to talk about, you can use it for embedding generation, but also like you can use it independently as well for a specific type of task, for example classification kind of task. We'll discuss why, but yeah, so there is a very good leaderboard on Hugging Face on the embedding models. You can choose any sentence embedder from there as well, a sentence transformer from there as well, or you can use any model, but you have to like try different models and then finalize the model. So over here we are going to review this blog as well as a fourth strategy to improve the performance of the RAG. So what they have written over here, BERT was released in 2018 and yet still very widely used. In fact, it is currently the second most downloaded model on the Hugging Face and more 68 million monthly downloads. Yeah, and only second to another encoder model fine-tuned for retrieval. Okay, that's because the encoder-only architecture makes it ideal for the kind of real-world problems that come every day, like retrieval, such as RAGs, classification such as context moderation and entity extraction, right? So as we know, in RAG the primary goal is retrieval and then entity extraction, right? Sometimes classification as well. Finally, 6 years later we have a replacement releasing modern BERT. Modern BERT is a new model series that is parento improvement over BERT, the younger sibling across the speed and accuracy. This model takes dozens of advances from recent years and work, so blah blah. So now they have discussed on decoder only model and encoder only model. Then what is the difference between two? So as you know, some of you might already know and some of you might be new to the field, might not know, GPT is on a decoder only architecture, right? So the way GPT is trained, it is trained for generating the next word, right? So when you train a model like GPT, you do mask multi-head attention. So basically when you train such a model, you mask in your training data set, you mask all the keywords following a particular keyword that you want to train the model for. Now what that results in, so GPT like models pay more attention to the words that are behind a particular sentence, right? But they can look only backwards. But the encoder only models are trained for both backward and forward lookups. So this is, while the decoder only models can do work of encoder only model, they are hamstrung by a key constraint. They are generative models. They are mathematically not allowed to peek at the later tokens. So this is very important. They can only ever look backwards. They can't look forward because they are trained to generate the next word. Okay? This is a constraint to encoder only models which are trained so each token can look forward and backward bidirectionally, and they are built for this, and it makes them very efficient at what they do. Okay? Basically a frontier model like OpenAI is like a Ferrari F23, that is an obvious triumph of engineering designed to win races, but it takes a special pit crew to change the tires. You can't just buy one yourself. On the contrast, BERT model is like Honda Civic, that is also an engineering triumph, but more subtly, since it is engineered to be affordable, fuel efficient, etc, etc. So okay, so basically this is a major difference between a decoder only model and encoder only model. A decoder only model is designed to look backward, whereas encoder-only model can look backward and forward. So it makes an encoder-only model a very good choice uh, for tasks like semantic analysis, uh, your classification, your retrieval. The embeddings generated by these models sometimes tend to be more efficient as compared to the decoder-only model. So you can also, and on top of this, right? Basically, encoder-only models are smaller in size. They are cheaper to run, and their requirements, hardware requirements, are way less than encoder-only model, decoder-only models. So over here they have discussed about the performance, and then about the efficiency, and yeah, basically some other few things, but the crux of this whole um, like whole blog is simple, and I have made it very simple for you, that why decoder only models sometimes are not best suited, and they have also discussed. By the way, this blog is very good read, and you can also read about this section, global and local attention. It will also, and then padding and strides, they have also discussed about that. So but this is like in the nutshell or in the crux what they are majorly talking about. So this is a very good read on decoder only models. You can definitely, so we discussed 4 strategies in this video, which is like first generating the vector embeddings along with BM25 search. Then basically you do summarization of your text and then add it to the chunks, then the size of the chunk, and then the choice of the model. These are the like few techniques you can use to improve the quality of your RAG. Basically you can improve to ensure that your RAG gives you correct and relevant chunks around the query. Then there will be other techniques that we will discuss in some later video, where we will discuss things like LLM as a judge, how you can ensure that the answers returned by your query are relevant to your query. There are other multi-model approaches to improve the cost of your cost plus accuracy and testability of your RAG. We will not discuss all those techniques in this blog, but we will discuss it in a separate video. So that's all for today. I hope you like this video, and thanks for watching this video. Thank you.